In this lesson, I'm going to show you how to transform a velocity versus time graph to a displacement versus time graph. Now, to do the transformation, it all involves studying the area either above the x-axis or below the x-axis. Now, area of a velocity versus time graph is going to be equal to the change in position from the previous position. So we're going to begin with the first section of the graph, this area right here. And the area of a triangle is equal to 1/2 base times height. So in this case, our base is 10, and our height is 60. Now, it's positive 60 because it's positive velocity, so I'm going to put that positive in there. And that's going to work out to positive 300 meters. And the positive right here indicates that the object is moving in the positive direction. So down here in the chart, I've prepared just to kind of summarize all the data, and that'll help create our displacement versus time graph. At time 0, there's no change in time, obviously, so there's no area, so we're going to begin from a position of 0. The area we calculated is positive 300. Now, I've done some of the other calculations. We see that this region right here, that works out to 300 also. That would be 5 times 60, which is equal to 300. And then this area right here, that equals to 305. But let's study this area which is below the horizontal line. So this right here is going to be equal to 1/2 times 10 for the time from 30 to 40 times negative 40. Okay, so the negative right here refers to direction. So that works out to negative 200 meters, which means that the object is moving in the negative direction. So this becomes negative 200. And if we look at this region right here and calculate it, we find out that it calculates to a negative 300. Again, it would be, in this case, 40, 50, 55 times minus 40, negative 300. So now what we're going to do is we're going to use these numbers to locate the object at any given time. So at 10 seconds, the object has gained 300 meters in the positive direction, so it's located at 300 beyond the initial 0. At 15 seconds, it has gained an additional 300, so now we're up to a position of 600. Then at 30 seconds, it's gained another 305, which places it at, 905. But at 40 seconds, what happens is it's moved in the opposite direction 200, so this becomes 705. And it now continues in a negative direction, so we subtract 300 from 705, which is 405. So this is actually the final position of the object after it undergoes all of these velocities. So now let's graph this. What we'll do is we'll put displacement over here, measured in t, and here we will put time, measured in seconds. Start off with 0 here, and then given our range of numbers, right here. What I've decided to do is on the x-axis, I'm going to go by tens. $40 and then $50. And on the y-axis, I'm going to go up by 200. And this will be 1,000. Okay, so now what I'm going to do is I'm going to start plotting these numbers. We're going to start off at 0, 0, right? That's that data pair. And then at 10 seconds, we're at 300. That places it right there. And what I'm going to do is I'm going to sketch, actually I'll sketch the lines later. Let's plot all the dots first of all. So at 15 seconds, we are going to be at 600, so that would be right there. And then at 30 seconds, we're going to be at 905, which is just a little bit above there. I may have exaggerated that a little bit. And in 40, we're at 705, so a little bit over there. And then at 50, we're at 405, and that would place it right over there. So now let's figure out how to connect these dots. We want to draw a smooth possible line. And if I go over here, line 1, we notice that that object is accelerating, it's speeding up. So that would create a curve going like that. Okay, so that's a curve because it's speeding up. Here at the second part, between 10 and 15, we're moving at a constant speed of 60. So this has to be a straight line. So let me use a ruler to do that. So that'll be a straight line. And now what are we doing here? It looks like we're slowing down until we reach a speed of 0. Okay, so we're going to slow down. So that would be an eyebrow curve. Okay, this is a smile, straight line, eyebrow. And now when we, from the 0 speed, we now increase our speed in a negative direction. So it looks like this is a parabola. So this actually should be smooth going like that. Okay, so this part right here is also a curve. So this is the third part and this is the fourth part. I'm just going to point out right here v is equal to 0, which is why we have a tangent line right here. Okay, and that indicates the slope of an x versus t graph indicates what the speed is. The speed is 0 right at that point. And what's happening, we're changing direction. In order to change direction, we have to end and start at a speed is equal to 0 as we make that direction change. And then finally, this last part right here, 5, we are we are slowing down in a negative direction. So that would be a curve that looks something like that. And that's how you transform a velocity to a displacement versus time graph.